All right, hello everyone. This is the constant velocity lab wrap up, just in case if we don't get to it in class or if you need to see it again. All right, so basically you have a graph, okay, that looks like this. You need to make sure your graph is labeled, okay, with the variable and the units. Okay, if you'd like to call x position, you can do that. Or time. Okay, the important thing is it's not distance. It's not displacement. It is position. Okay, that's very, very important. All right, because it's just a number reading on the number line. Okay, all right, so in the lab from the boat that we did, it kind of started like this. Okay, and it looked sort of like this. All right, so you got your Desmos equation. So in Desmos, you would type y1 squiggle mx1 plus b, all right, and then that tells the computer program that you have recognized this as a line and you'd like it to do a curve fit and find out the values based on your data that you put in, okay, right? An algebra equation, so if you saw the same idea of a line in algebra, you might see it like this, y equals mx plus b, okay, and then the lab equation we're going to do in a minute, all right? Okay, so when we look at this graph, all right, we see that it's a line. So we would say that the verbal model of this graph is basically just telling me what is happening to the relationships between the variables, okay? And you almost always write it this way. As the x thing increases, the y thing does whatever it does, okay? So as the time increases, that's my x variable. Okay, as the time increases, all right, the position increases, okay, and we want to make some kind of notation that this is a line, okay, and we can't say proportionally, which we'll get into later about why that's not right in this case, okay. As the time increases, the position increases. I'm just going to say linearly, I guess is probably good enough, right, because I'm trying to note that the shape of this is a line. Okay, so as the time increases, the position increases linearly. So what that means, right, like when you look at your data table, right, it would look something like this. Okay, and it's probably not this super clean, but you get the idea, right? So this is back to what we were talking about, something moving at a constant speed. Every 1 second that passes, the position increases by the same amount every time. Okay, that's what clues us in that this is a constant speed or constant velocity. We'll get into that difference in a minute. Okay, all right. So when we want to write the lab equation, all right, we're going to plug in what we know. So instead of y, on our y-axis, it's position. Okay, and then we know the slope of our line. So, right, Desmos gives you that little box, okay? You need to pull those values off the box. That's the point of doing this. And we will calculate some slopes by hand also, okay? But when we calculate the slope, so that would be like x1, y1. I'm pretty sure everyone has done this in algebra, okay? When you're calculating this slope, you're going to do y2 minus y1 over x2 minus x1. Okay, and you're going to pull off these two values just like you do in algebra class, or for us, we're going to let the computer go ahead and get that value for us in this case, okay, but not always, so you need to know how to calculate it. Okay, so let's say if this were my data, it would be 20 meters per second, okay, right, and then the units, right, are going to be meters per second, oops, because when I go in my rise direction, that's meters, and in my run direction is seconds. Okay, so the units are very important. It's the y units over the x units. Okay, so 20 meters per second. Okay, then I need my x variable, which is time. Okay, and then plus whatever yours is. So let's just pretend like we're not going to use this data because ours actually in this lab was a negative. So I'm just going to go ahead and change that. Okay, so I could say like plus negative 30 meters or whatever. Okay, or you could just say minus, right? Because plus a negative or minus, that's the same thing. Okay, all right. And since this is the y-intercept, right, it's where the y-axis crosses. So this would be at negative 30 in this case. All right. It's going to be meters because it's on the y-axis. It's a y variable. Okay, so this is the lab equation. All right, so when I look at this, I could write this in more variables, right? This is what we're going to try to do. Well, let's do the slope first. Okay, so let's just write this. All right, so this slope, okay, is 20 meters per second, and we do not want to use the word per, okay? This is not a very descriptive word, all right? So we like to say we're going to write what we call a for every statement, and this will serve you well in chemistry as well, all right? So really, 20 is the same as 20 over 1. Okay, so you kind of read it from the bottom up. So you say for every 1 second of time that passes, right? And I want you to say the variable name. Okay, so for every 1 second of time that passes, all right, that is this part. Okay, and then our other variable is, whoops, that's not right. Okay, the position, that's the other variable, increases, because it's a positive, by 20 meters. Okay, so that gets that idea that at 1 second passes, it goes 20 meters. Another second, another 20. Another second, another 20. Okay, so now we're just putting a number on this. So see, this is pretty close to the verbal model. Okay, but the slope explanation has a number in it. All right, that makes sense. All right, and I want you to write it like this, and I really, really need you to write the variables. Okay, for every 1 second of time that passes, the position increases by 20 meters. Okay, all right, y-intercept. Let's look at the y-intercept. Okay, so now we're looking at this number. All right, so the y-intercept on a graph is a point. Okay, the slope is a delta, it's a change, but the y-intercept is a single point. All right, which is, in this case, 0, -30. All right, so if I put units on this, this is actually 0 seconds, -30 meters, right? Because this is the x, this is the y. So if I'm going to write my y-intercept as a sentence, I would say when the time is 0 seconds, the position, notice I'm using the variable names again, whoops, is -30 meters. Okay? All right, so that's how I'd write the y-intercept. All right. Okay, so that's kind of how you're going to analyze a graph. Now, this tells us about this particular simulation and this particular boat, which, like, that's terrific. Great. All right, but I need to be able to generalize this for anything. All right, so what you have is you had this lab equation, position equals 20 meters per second multiplied by the time minus 30 meters, okay, or plus -30 meters if you want, all right? So I need to be able to use this for anything that's moving at a constant speed, not just this boat in this simulation. So I'm going to start to turn these into variables, okay? So position, we're going to call x, okay? What is this number telling me? 20 meters per second. That's like 20 miles per hour, 20 kilometers per hour, okay? All of these are a measurement of how fast something's going, all right? And mathematically, we're actually, instead of speed, we're going to call this velocity. Okay, we're going to call this velocity, all right? For now, let's just call it that, okay? Velocity, all right? Times t for time, okay? And then plus, this is also a position, so this is also going to be an x, all right? So I have x equals vt plus x, all right? But I have two x's, but those aren't really the same thing because this one is the initial, so we're going to put a little I here. Okay, and this one is, we're going to call it final, right? It doesn't have to be at the very end. It just means at that time. So we're going to call this final. Okay, so then this is going to be what we call our physics equation. So if you like look up in a book or something, this is the equation that's going to be for something moving at a constant velocity. Okay, all right, where v is the slope of a position versus time graph, and xi is the y-intercept of that graph. Okay, and then x and t you're going to plug in. All right, okay, let's see. Do I want to make this a different video? Yes, let's make this a different video. I'm going to stop here.